Alright, let's cut the fluff. A hot minute ago, humanoid robots were glorified circus acts, strutting their stuff at tech expos, wowing crowds with dance moves, or flipping pancakes for clout. In this video, we're spilling the tea on how Foxconn and Nvidia cooked up a robotic nurse that's tending to patients, how Singapore is flirting with a humanoid security guard straight out of a sci-fi flick, and how a startup with a cool $27 million is gearing up to unleash robots on shipyards. Plus, we've got Titan, a beefy bot built to slug it out in the great outdoors, and a slick AI trick from Carnegie Mellon that's teaching robots to shove, yank, and swing doors like pros. The robot workforce is crashing the party, and it's time to dish. First up, Nurabot, developed by Foxconn, Nvidia, and Kawasaki, debuted at Computex 2025 and is now in trials at Taichung Veterans General Hospital in Taiwan. This humanoid robot is designed to ease the strain on healthcare systems facing nurse shortages and aging populations. Nurabot stands about 1.5 meters tall with a sleek, white exterior and articulated arms for dexterity. It's powered by Nvidia's Jetson Orin platform, which processes data from high-resolution cameras, ultrasonic sensors, and microphones. These allow it to navigate hospital corridors, avoid obstacles, and interact with patients. Its natural language processing (NLP) system, trained on over 1,200 voice commands in languages like Mandarin and English, enables it to understand and respond to patient requests. Nurabot reduces nurse workload by handling repetitive tasks, delivering meals, medications, and supplies, freeing staff for critical care. In trials, nurses reported a 30% reduction in time spent on non-medical tasks. It addresses labor shortages. Taiwan's nurse-to-patient ratio is 1:12, well below the ideal 1:8. With global healthcare demand rising, WHO predicts a 10 million health worker shortage by 2030. Nurabot could become standard. It's not flawless. The robot's $200,000 price tag is steep for smaller hospitals, and maintenance costs add up. Its AI can misinterpret complex emotional cues like distress mistaken for agitation, potentially delaying human intervention. Its ability to learn and adapt is impressive, and the workload relief for nurses is undeniable. But it's not a replacement for human caregivers. More like a trusty sidekick. Next, Certis in Singapore is testing a humanoid robot from Agabot, introduced in May 2025 as a research project for building security, customer service, and facilities management. Agabot is a 1.7-meter humanoid with a humanoid face display for approachable interactions. It uses a combination of LiDAR, thermal cameras, and facial recognition to patrol environments. It navigates using simultaneous localization and mapping, SLAM, building real-time maps of buildings. Agabot enhances security without replacing humans, augmenting teams in high-traffic areas like malls or offices. Its $150,000 cost is a barrier for smaller firms, and maintenance requires specialized technicians. Human-robot interaction isn't seamless. Some visitors find Agabot's presence intimidating. Plus, it's still in research, so real-world reliability is unproven. Now let's move up to Persona AI, and they are sprinting out of the gate. In Houston, Persona AI raised $27 million in May 2025 to develop humanoid robots for shipyards, partnering with HD Hyundai for deployment by November 2026. These 1.8-meter robots are built for heavy-duty tasks, with reinforced titanium alloy frames and hydraulic actuators for strength. They use a hybrid AI system combining reinforcement learning and computer vision to perform tasks like welding and material handling. Their sensors achieve half-millimeter precision, critical for shipbuilding's tight tolerances. For example, they can weld seams on a hull while adjusting for vibrations and heat distortion. They're designed for robotics as a service, with companies leasing them for $10,000 a month. Shipyards face chronic labor shortages. U.S. shipbuilding needs 50,000 more workers by 2030. And these robots fill the gap. They improve safety by handling dangerous tasks, reducing workplace injuries. The ROS model lowers upfront costs and their precision boosts efficiency, cutting production time by 15% in simulations. The robots are complex, requiring skilled technicians for maintenance, which smaller shipyards may lack. Job displacement is a concern. Welders and laborers may face reduced demand, potentially impacting local economies. Initial setup costs, even with ROS, are high, limiting adoption to large firms. The ROS model is smart, but the tech's complexity and job impact are real issues. They're ideal for mega shipyards, but less practical for smaller operations. And they are not the only one in this space. Roboforce launched Titan in May 2025, a humanoid robot for harsh environments like mining and solar farms, backed by $15 million in funding. Titan, standing 1.9 meters, is modular, with interchangeable bases, wheels or tracks, for varied terrains.
From AI robotic domain, technical angle, there are two things matter the most. One is the pure computational power. In recent more than 8 years, it goes up more than 1,000 times. And second is the availability. Startup like us have access to that level of computation power. I think that is under the hood what matter the most. That moment is availability plus that pure computational power, turning the methods, models, and algorithm from not usable to great.
Its AI, running on a custom SoC, integrates data from tactile sensors and thermal imaging to handle tasks with 1 mm precision. It can lift 40 kilos and has a 2,000 mm arm reach, ideal for moving heavy materials. A unique feature, its sensors detect material textures, distinguishing between slick metal and rough stone, improving grip accuracy. Titan focuses on 5 primitive actions: pick, place, press, twist, connect, covering most industrial tasks. It runs 8 hours on a single charge, recharging via solar or grid power. Titan excels in environments too dangerous for humans, like mines with 1.2 fatalities per 100,000 workers annually. Its modularity allows customization, and the 5-action focus simplifies training, reducing setup time by 25% compared to traditional robots. Pilot programs in manufacturing and space tech show a 20% productivity boost. The $15 million funding supports scalability, with clients like solar farms adopting it for panel installation. At $180,000 per unit, Titan's cost is prohibitive for small operations. Carnegie Mellon University's Falcon framework, introduced in 2025, isn't a robot, but a control system Falcon tackles forceful loco manipulation. Walking while applying force, like pulling a cart or opening a door. It uses 2 AI agents, one for leg movement, one for arm actions, sharing data in real time via a neural network. This ensures balance under stress, handling up to 100 newtons of force, 30% of a robot's weight. Sensors on the robot's joints and feet provide feedback, adjusting posture dynamically. For example, when pulling a 50-kilogram load, Falcon recalibrates leg torque to prevent tipping. It's trained on diverse scenarios, improving arm accuracy by 100% over older systems. Falcon makes humanoids more versatile, enabling tasks in construction, logistics, or emergency response. Its dual-agent approach reduces falls by 40% in tests, crucial for unpredictable environments. It's platform-agnostic, applicable to various robots, and could lower development costs for manufacturers. Research applications like disaster response could save lives. Falcon is a breakthrough for robot control, with balance and force handling that push the field forward. But it's academic for now, with practical limits and high costs. It's a foundation for future robots, not a ready solution. Rating 7.5 out of 10. Promising, but needs real-world proof. Quick break for our sponsor, Outskill. So what's the big picture? These robots, Nurabot, Agabot, Personas bots, Titan, and Falcon, are tackling real problems. They're easing nurse burnout, securing buildings, building ships, working mines, and pushing robotic limits. The tech is solid. AI-driven adaptability, precise sensors, and robust designs make them viable. Benefits are clear productivity, safety, and labor gap solutions. But downsides loom: high costs, job losses, privacy risks, and reliability issues. My take? They're tools, not replacements. We need policies to retrain workers and manage ethical risks. What do you think? Can we balance progress and people? Drop a comment, hit that like, and I'll see you next time.